Hello everybody, how are you all doing? My name is Askar Khan and in this video we will understand real numbers and the number line. By the end of this lesson, you will be able to classify and graph and compare real numbers. And you will also be able to find and estimate square roots. So welcome to the lesson. Now let's try to understand this key concept of square roots. A number a is a square root of a number b if a squared is equal to b. For example, 7 squared is equal to 49. So 7 is a square root of 49. Let's try few. 2 squared is equal to 4. So 2 is the square root of 4. Similarly, 3 squared is equal to 9. So 3 is the square root of 9. 4 squared is equal to 16. So 4 is the square root of 16. And so on. 5 squared is equal to 25. So 5 is the square root of 25. So let's look at the formal way of representing the square roots. Now you can use the definition of the square root to find the exact square roots of some non-negative numbers. You can approximate the square roots of other non-negative numbers. Now the radical sign, the radical sign indicates a non-negative square root, also called a principal square root. So this radical sign indicates the square root of a non-negative number, and this is the square root of a non-negative number is also called as the principal square root. Now the expression under the radical symbol, this one, is called the radicand. This a is called the radicand and the symbol is called the radical symbol, and together it is called a radical. So let's deal with some of the problems with this symbol, the radical symbol. Let's try to solve this problem, simplifying square root expressions. What is the simplified form of each expression? Square root of 81 is how much? It is 9. Why? Because 9 squared is 81. That's the reason. 9 is the square root of 81. Let's try another one. What is the simplified form of this expression? Square root of 9 over 16. So you can actually split the square root. You can write it as square root of 9 over square root of 16. And square root of 9 is 3. Why? Because 3 squared is 9. And square root of 16 is 4. Why? Because 4 squared is 16. So the square root of 9 over 16 is 3 over 4. Great. Now let's see whether you got it or not. Try this. You can pause the video and then try it out and then see how you have worked. What is the simplified form of each expression? Square root of 64 is 8. Why? Because 8 squared is equal to 64. And next, what is the square root of 25? It is 5 because 5 squared is 25. Next, what is the square root of 1 over 36? For easy understanding, you can split the square roots for the numerator and the denominator. Square root of 1 is 1 and square root of 36 is 6 because 6 squared is 36. Try the last one. what is the square root of 81 over 121? Split the square roots, square root of 81 divided by square root of 121. And square root of 81 is 9 and square root of 121 is 11 because 11 squared is 121. That's great. Let's move on and solve another type of a problem. So now let's move on. The square of an integer is called a perfect square. For example, 49 is a perfect square. Why? Because 7 squared is equal to 49. Or we can also write it as square root of 49 is equal to 7. So 49 is called a perfect square because 7 squared is 49. Similarly, let's take 5 squared is 25. So 25 is called a perfect square. So can you guess few more perfect squares? What about 6 squared, which is 36, and 36 is a perfect square. So square root of 36 is 6. What if the radicand is not a perfect square? Let's take, for example, square root of 19. Now we don't have any number that if you square you will get 19. So 19 is not a perfect square. So how do we find the square root of 19? We use approximations to find the square root of 19. We will take up an example and see how we do that. Let's try this. Lobster eyes are made up of tiny square regions. You can see that in the picture over here. These are the eyes of the lobster. The picture is enlarged. Under the microscope, the surface of the eye looks like graph paper. A scientist measures the area of one of the squares to be 386 square microns. What is the approximate side length of the square to the nearest micron? So how will you do that? Of course, you can take a calculator and find out the square root of 386. That's one method. But without a calculator, how can we estimate the square root of 386? Now, if you observe, the square root, the perfect squares closest to 386 are 361 and 400. These are the squares, perfect squares that are closest to 386 because 386 is not a perfect square. So what is the square root of 361? The square root of 361 is 19 because 19 squared is 361. And what is the square root of 400? It is 20 because 20 squared is 400. And square root of 386 then lies between, the answer for square root of 386 will be between 19 to 20. And since 361 is closer to 400, so square root of 386 will be approximately 20 microns. Get the idea of how you find the approximation of a square root, the value of which is not a perfect square. So square root of 361 is 19, square root of 400 is 20, and 386 lies closer to 400, so the square root of 386 is 20 something microns. And if you use your calculator, the square root of 386, by using a calculator you will get approximately 19.6, which is again closer to 20. So this is how you find the square root of a non-perfect square. So find the two perfect squares that are within this range and then figure out the answer. Let's see whether you got it or not. What is the value of square root of 34 to the nearest integer? So how do we go about? Let us figure out the two perfect squares that are closer to 34. So 25 and 36. Why? Because 5 squared is 25 and 6 squared is 36, and 34 lies between these two perfect squares. So what is the square root of 25? It is 5. And what is the square root of 36? It is 6. So what will be the square root of 34 then? It will lie approximately between 5 to 6. Since 34 is closer to 36, approximately square root of 34 will be 6, approximately. And if you use your calculator, square root of 34, by using your calculator, approximately you get 5.8, which matches with our mental approximation. Great going, excellent. Let's move on further to understanding the other part of the concept of the lesson. Now let's try to understand what is a set. A set is a well-defined collection of objects, and you can classify numbers using sets. So what is a set? It's a well-defined collection of objects written under parentheses. For example, let's take a set of furnitures. What do you have? You will have a chair, table, maybe a cupboard, and so on. So this is a set of furniture. It is always enclosed within brackets. Each is called an element of the set. Each is called an element of the set. So if I ask you how many elements are there in this set F, there are 3 elements. Now a subset, let's take this, a subset is nothing but a set consisting of elements from the given set. Now if I pull out only 2 elements from this set, let me pull out chair and table and write it over here, chair and table. So now this becomes the subset of this set F. So we know now that a set is a well-defined collection of objects. Each object is called an element of the set. A subset of a set consists of elements from the given set. You can list the elements of the set within brackets. So with this understanding, the basic understanding of sets, let's move on to understanding the set of numbers. Let's understand what is a rational number. A rational number is any number that can be written in the form a over b, where a is an integer and b is also an integer, and also b cannot be equal to 0. The denominator cannot be 0. So any number that can be written in the form a over b, where a and b are integers and b cannot be 0, is called a rational number. For example, what do you think about 3 over 5? Is this a rational number? Yes, because 3 is an integer and 5 is an integer. And of course, the denominator is not 0. So this is an integer. What about 19 over 15? It is an rational number. What about 5? Is it a rational number? Yes, because I can write 5 as 5 over 1. It's the same thing. Now 5 is an integer, 1 is an integer, and the denominator is not equal to 0. So this is a rational number. So in terms of fractions, we know that this is a rational number. A rational number in decimal form is either a terminating decimal or a non-terminating repeating decimal. For example, if you write a rational number as a decimal, it's going to be say 4 or 5.45, a terminating decimal. It stops after a few digits. 8.36, 0.85. All these are examples of rational numbers. If the decimal is not terminating, then either it will be repeating. For example, 0.41666 and so on. You can write this as 0.416 is repeating. Or you can also write it as say 2.121212. If you observe over here, the numbers after decimal 1, 2 is repeating. So this is a rational number. So we know how to figure out a rational number when it's given in the fraction form, when it is given in a decimal form. In decimal form, either it's terminating decimal or it's a non-terminating but repeating decimal. Now let us look at some of the subset of the rational numbers, and you know what subset is. Let's understand what are natural numbers. Natural numbers are 1, 2, 3, 4, 5 and so on. You can plot these natural numbers on the number line like this. On 1 you plot here, and 2 is over here, and 3. On a number line, all the numbers on the right hand side of 0 are called positive integers, and all the numbers on the left hand side of 0 are called negative integers. And 0 is neither positive nor negative, but it is an integer. So we know what natural numbers are. Numbers that begin with 1 and move on to 2, 3, 4, 5 and so on. What are whole numbers? Whole numbers are numbers that begin from 0. 0, 1, 2, 3, 4 and so on. And you mark it on the number line like this. And what about integers? What are integers? Integers are numbers that are both negative and positive and 0. And you mark it on the number line in this way. So these are the subset of rational numbers. Now what are irrational numbers? An irrational number cannot be represented as the quotient of two integers. You cannot write an irrational number or represent an irrational number as a quotient of two integers. The decimal form of irrational numbers is non-terminating and not repeating. If you observe this, you find that the decimal goes on and there is no repetition of the digits over here. There is no pattern over here. So such a number is an irrational number. Take for example another one over here, pi. What is the value of pi? 3.141592, and it goes on. Are the digits repeating in a pattern? No, they are not. So pi is an irrational number. So we know what's the difference between a rational number and an irrational number. Some square roots are rational numbers and some are irrational numbers. If a whole number is not a perfect square, its square root is irrational. Let's take for example square root of 4. Is it a rational number or an irrational number? It is a rational number because 4 is a perfect square. So square root of 4 is 2. So this is a rational number. What about square root of 25? Is it a rational number or an irrational number? It is a rational number because 25 is a perfect square and square root of 25 is 5. So it is a rational number. Now tell me, what is square root 3? Is it a rational number or an irrational number? Since 3 is not a perfect square, it is an irrational number because the decimal of square root of 3 is 1.732050 and it goes on. So this is an irrational number. Can you guess what will be the square root of 10? Is it a rational number or an irrational number? Is 10 a perfect square? No. So square root of 10 will be an irrational number. And square root of 10, if you use your calculator, it's going to be 3.16227 and so on. So this is an irrational number. So these are irrational numbers. Great. We have understood what rational numbers are, what irrational numbers are, and what are the subset of rational numbers. Now let's try some problems. Let's try this problem. Classifying real numbers. To which subset of the real numbers does each number belong? Real numbers. What are real numbers first of all? Real numbers are nothing but rational numbers and irrational numbers put together. They are all real numbers. So to which subset of the real numbers does each number belong? 15. Can you guess? Does it fall under natural numbers? Yes. Is it a whole number? Yes, because whole numbers are from 0, 1 to 3. Is it an integer? Yes, because integers are all negatives and 0 and positives. So is it a rational number? Yes, because it can be represented in the form a over b, 15 over 1. So 15 falls under natural numbers, whole numbers, integers and rational numbers. What about negative 1.4583? Is the decimal terminating? Yes, it is terminating. So if the decimal is terminating, is it a rational number or an irrational number? Good, it's a rational number. So this is a rational number. What about square root of 57? First of all, is 57 a perfect square? It is not a perfect square. Therefore, is it rational or irrational? It is an irrational number. Great, that's excellent. Let's move ahead. So here is a concept summary. All real numbers, all rational numbers and irrational numbers fall under the category of real numbers. Rational numbers are those that can be expressed in the form a over b, where the numerator is an integer, the denominator is an integer, and the denominator cannot be 0. In decimal form, it terminates, or if it does not terminate, the digit repeats. And perfect squares are also rational numbers. Under rational numbers, you have integers, you have whole numbers, and you have natural numbers. So this is a summary concept summary of real numbers. Let's understand what is an inequality. So what is an inequality? An inequality is a mathematical sentence that compares two values using the inequality symbols. And what are the inequality symbols? Less than. This is the symbol for less than. greater than. This is the symbol for greater than. Greater than or equal to, that is the symbol. Less than or equal to, these are the inequality symbols. And when you compare two mathematical quantities using these symbols, then it is called an inequality. For example, let's take, compare 4 with 10. What will you do? Since 4 is less than 10, we say 4 is less than 10. Let's take another example. Square root 25, square root 4. Compare. What is the inequality in this? Since square root 25 is 5 and square root 4 is 2, we say that square root 25 is greater than square root 4. So do you get it how we do this? So now let's use this understanding to solve some problems. So let's try this. What is an inequality that compares the numbers square root 17 and 4 1/3? What is the inequality? Is square root 17 less than 4 1/3, greater than 4 1/3, or less than or equal, or greater than or equal? We need to compare that. So square root 17, what is the decimal equivalent of square root 17? It's going to be 4.12310, and it goes on. What is the decimal equivalent of 4 1/3? That is 4.3333, and it repeats. Since 3 repeats, we can mark it this way. So now it becomes very clear that square root 17 is less than 4 1/3. So you get it how we compare two quantities for inequality. That's great. So let's see whether you got it. What is an inequality that compares the numbers square root of 129 and 11.52? So what is the decimal equivalent of square root of 129? It is 11.35 and something. And we have the number 11.52. So can you now guess what is the inequality? So square root of 129 is less than 11.52. We can also write 11.52 is greater than square root of 129. Either way. Great going. Let's try another one. Let's try this. It's a multiple choice question. You're supposed to choose the correct answer. What is the order of square root 4, 0.4, negative 2/3, square root 2, and negative 1.5 from least to greatest? You must arrange the numbers from the least to greatest. The first step is try to convert or change all those non-decimal numbers into decimals. So let's do that first. So square root of 4 is 2. And then we have 0.4 as it is. Let's change negative 2/3 into decimal. And that's approximately going to be negative 0.67. And how much will square root of 2 be? Approximately it's 1.414 or 1.41. Now, can we mark all these numbers on a number line? So if we mark all these numbers on a number line, how do they look like? They look like this, from smallest to greatest. So we have the smallest number as negative 1.5, and then negative 2 over 3 because that's negative 0.67, and then 0.4 and square root 2 and square root 4. So which is our correct answer? The correct answer is C. So great job. And with this we complete the lesson. So great going. You have put an excellent amount of hard work so far, and keep working and keep putting on your hard work, because remember, your results are in proportion to the amount of work that you put in. So keep trying and keep working, and thank you for watching this video. My name is Askar Khan and I run a math channel on YouTube called Wisdom Outlined, and there's a self-help channel of mine on YouTube channel. It's called Principles Outlined. If you want math private lessons, you can reach me on my WhatsApp number 00966 507081702. Please do subscribe to this channel and click the like button and share this video with one and all. Thank you for watching and be prepared for the next lesson.